Hi everyone, now here we have been discussing one of the most important chapter of chemistry in 10th class is acids, bases and salts. Before going to this session, we can discuss some introductory part. I am showing to a wonderful picture to you. Once look at slide, yes. So we are observing this picture name is, the flower name is the hydrangea. This picture consists of different colors. Those are red, violet, blue color, etc. So what is the connection between acids, bases, salts and this picture? Now let us discuss. So this hydrangea flower can show different colors. Why? Because it's nothing but this flower can be present in acidic soil. They can show one color. This flower can be present in basic soil, then can be shows another color. So once look at bird, if the flower present in basic soil, it is in the color of pink, whereas the flower present in acidic soil, the flower shows blue in color. So based on nature of soil, we can say the color of the flower. Yes or not? Yes. Now I am showing another flower to you. Yes. This flower name is Petunias. So this flower also consists different colors, pink color or violet, that is a purple color they are seeing. Yes, why? Because it's nothing but in the alkaline medium, Petunias flower shows violet in color, whereas in acidic soil this flower can shows purple in color. So acids, bases can assurance give the nature of the soil and color of the flowers. Yes, this particular flowers are called as pH sensitive flowers. So hydrangea and petunias are the pH sensitive flowers. So generally pH is the term of negative logarithm of concentration of H plus ions. So this term can be related to the concentration of acidic or basic. Okay, so these things can be later discussed, no problem. So once look at the board, generally acid is the term derived from acidos. According to Greek language, acidos means sour to taste. So acid is the substance having sour to taste. So examples, we consider lemon, curd, tamarind, etc. These are all considered acids. Why these substances having sour in taste? Because of due to these are consisting some acids. For example, lemon consists of citric acid and curd consists of lactic acid and tamarind consists of tartaric acid. Because of due to these acids, these substances having sour in taste. Similarly, what is meant to be base? Based on taste, generally bases are in bitter in taste. Generally bases are in bitter in taste, they have slippery in nature. They have slippery in nature. and soapy to touch. For example, I consider example for bases. Those are shampoo and soap. These are the examples for bases. Why these bases are nothing but these are having bitter in taste and slippery in nature and soapy to taste, soapy to touch. Okay, generally soaps are the bases. Soaps can be prepared by saponification reaction. So saponification here term is nothing but related to this alkaline hydrolysis. So it is a basic hydrolysis. Okay students, so according to taste and touch, acid is nothing but sour in taste, whereas base is nothing but bitter in taste and it is soapy to touch. Okay, this is the old concept. This is old concept. So we have different definitions about what is meant by acid, what is meant by base. We have several theories to explain for the definitions of acids, bases. So they are Arrhenius concept is there, Brownsted concept is there, and Lewis concept is there. But in out of three, we can discuss only Arrhenius concept in SSC point of view. According to Arrhenius, acid is nothing but, first of all, acid is a substance. So these are the substances which can be dissolved in water to produce H plus ions. That is called acid. Suppose I consider example as HCl. HCl is a hydrochloric acid. When dissolving in water, it forms H plus and Cl minus ions. We know that Cl minus is chloride ion. And H plus is nothing but proton. H plus is nothing but proton. We know that what is meant by proton? Proton is the particle which can be obtained from hydrogen. So that's why H plus can consider as a proton. It is also called as proton. So according to Arrhenius, whenever the substances can be dissolving in water to produce or furnish protons are called acid. I take another example. It is H2SO4. H2SO4 is nothing but its chemical name is sulfuric acid. Sulfuric acid. It is also called as oil of withdrawal. H2SO4 is also called as oil of withdrawal. It is very important designation is there for sulfuric acid. It is a king of chemical. H2SO4 is the king of chemical. Okay, but you don't ask queen of chemical. Okay, H2SO4 is a king of chemical. When sulfuric acid is dissolving in water to produce 2 H plus ions and SO4 2 minus ion. SO4 2 minus is the sulfate. It is sulfate ion. Okay, this is also called acid. So according to Arrhenius, the substance can be called as acid in the presence of only aqueous medium. We consider aqueous medium must and should. There is no aqueous medium, the substance we can't consider as acid. So here very important point, those substances which can be dissolved in water. So here water is the aqueous. So in the aqueous medium, the substance can be produce H plus ions. That substance is called as acid. Okay, Arrhenius concept is failed because of due to absence of water. In the absence of water, Arrhenius concept is failed. Okay, so it is very important. It is very important point. According to Arrhenius, the substances which can be dissolved in water to produce H plus ions, that substance we can be called as acid. Okay. In these two conditions, in these two cases, H plus ions are produced. That is why we consider as these substances are acid. Okay. Now my question is, H plus can exist as a free ion? No. H plus ions can't exist in free alone. Why? Because these H plus ions are unstable. These H plus ions are unstable. That is why these H plus ions are again react with excess water in the solution, then form hydronium ions. So H plus ions can exist in more hydrated form only. H plus ions can exist in more hydrated form only. So hydrated form is nothing but, what is meant by hydrated form, sir? Hydrated form is nothing but when negative ion particles are surrounded by positive charged particles. This is a hydration. Suppose I consider, so this is H plus ions. So in that solution excess water is present. So water is nothing but structure, we know that, you know very well that structure of water like that. So this is H plus, this is water. This H plus react with water to form H3O plus ion. This is hydrated form, this is H plus, this is, we know that oxygen, hydrogen, it is a bond. Oxygen has more electronegative than hydrogen. Oxygen has more electronegative than hydrogen. We know that electronegativity is nothing but the tendency of an element to attract shared pair of electrons towards itself. Is nothing but, bond is nothing but two electrons. One of the electron belongs to oxygen, another electron belongs to hydrogen. Yes, sir. Because of due to electronegativity, oxygen can accept electrons. Okay. Then oxygen acquiring partial negative charge, whereas hydrogen can get partial positive charge. Now here this negative ion particle can be surrounded these H plus ions. That is the hydration. So H plus, water, like that negative charged particles are surrounding around the H plus ions. This is the hydration. This is hydration. So these H plus ions can exist in more hydrated form, that is in H3O plus ions. Okay. Otherwise these H3O plus ions again react with water, then form H5O2 plus ion. Next these H5O2 plus ions again react with water. H7O4 plus ion. These are all hydrated forms only. These are all hydrated forms. So H plus can exist in more hydrated form. H plus ion does not exist in free ion. Okay students, this is very important point. Okay. So definition I changed now. So those substances which can be dissolved in water to produce hydronium ions, that substance we called as a acid. So according to Arrhenius, base is nothing but those are the substances which can be dissolved in water to produce hydroxide ions. Now I consider one of the example. I consider one example, NaOH. This can be dissolved in water to produce or furnish Na plus and OH minus ions. Similarly, I take another example, KOH. When KOH is dissolved in water to produce K plus OH minus ions. Again I consider another example, calcium hydroxide, CaOH twice. It is a lime. When lime dissolving in water, okay, then produce Ca plus 2 and 2OH minus ions. In all cases, the substance produce OH minus ions in the aqueous medium. In the aqueous medium, here medium is very important according to Petunias. Okay, so that's why these substances can be regarded as a base. Okay, now most of the students, they are bothered about what is meant by base and what is meant by alkali, sir. Generally base and alkali both are same, sir? No. Base is nothing but those substances which are dissolving in water to produce hydroxide ions. But alkali is nothing but those bases which are soluble in water, that base is called as alkali. So for example, NaOH and KOH are the example for alkali. Why, sir? These bases again soluble in water. That's why these are called as alkali. Further, I give one sentence. So what is the relation between acid and base? Is nothing but all alkalis are bases, but all bases are not alkalis. All alkalis are bases, but all bases are not alkalis. Okay, students, this is the relation between alkali and base. Okay, are you getting my point? Okay, so we know that according to Arrhenius, those substances which can be dissolved in water to produce H plus ions, that substance is called as acid. Yes or not? Yes. Now once look slide. Yes, an acid is a substance that produces hydrogen ions when placed in water. I explain now. When acids or ionic compounds are dissolved in water, so here important, we are taking in aqueous medium. The ion splits apart from each other. So the compound can be dissociated into ions, is nothing but cation and anion. We know that cation is a positive charge, anion is a negative charge. Okay. Next, properties of acids. So properties here, both are physical and chemical properties are there here. So most acids generally taste sour. Acids generally sour in taste. They can react, it is chemical reaction. I can discuss later, no problem. React with many metals to form hydrogen gas. Generally acids are corrosive. They are corrode to the metals. They are damaging to the metals. Have a chemical formula that begins with hydrogen. So all acids, we are writing the chemical formula. Before writing the chemical formula, we are starting with letter H. So zinc metal can react with hydrochloric acid to form zinc chloride and produces hydrogen gas. So these things can be discussed later. Okay, students. Next, some common acids. So citric acid found in citrus fruits. It is used as a preservative. Lactic acid, it is found in yogurt produced by our muscles when they are overworked. Next, acetic acid, it is also called as vinegar. It is used as a preservative. Carbonic acid, H2CO3, or phosphoric acid, H3PO4, it is found in soft drinks. So hydrochloric acid, HCl, it is found in stomachs, aids in food digestion. Okay. Next, strong or weak acids, examples. Strong acids, examples, HCl, hydrochloric acid, it is stomach acid. Second one, H2SO4, it is a sulfuric acid. This acid is used in battery acid. Third one, HNO3, it is a nitric acid. Next, weak acids. Acetic acid is a weak acid. It is also called as vinegar. Next, citric acid. citric acid present in citrus fruits. Okay. So acid is these are sour in taste overall. They turn blue litmus to red. Whenever blue litmus paper can be contacted with acidic medium, then blue litmus can be converted into red. They give H plus ions in aqueous solutions. Acid corrode metals. Examples: strong acids, hydrochloric acid, sulfuric acid. Weak acid, acetic acid, oxalic acid, and citric acid. Okay. Why these are called strong acids? Why these are called weak acid? I can discuss later. Next session I will discuss that one. Why these are called as strong acids, why these are called as weak acids. Okay students. Now next one is concentrated acid. What is meant by concentrated acid? What is meant by dilute acid? These things also we can study later. Next, base. I already explained. So once listen, base is a substance that produces hydroxide ions when placed in a water. When bases or ionic compounds are dissolved in water, the ions splits apart from each other, so they can take dissociation. So whenever the compound can be dissociate, they produce ions as cation and anion. So in the base, anion is a hydroxide ion, whereas in acids, anion is a cation is a H plus. Okay. Next, properties of bases. Most bases are taste bitter, they feel slippery, they are corrosive, and have a chemical formula that ends with OH. So now common bases. Ammonia. Ammonia is one of the base. You know that chemical formula NH3. These are used as a cleaners and fertilizers to prepare fertilizers. Okay. Next one is sodium hydroxide. Its chemical formula is NaOH. These are used in soaps and drain cleaners. Next, magnesium hydroxide. It is also known as milk of magnesia. Its chemical formula is MgOH twice. It is used as an ingredient found in antacids. Okay. Now strong or weak bases. Strong bases. Examples: NaOH, sodium hydroxide. Second one, any alkali or alkaline earth metal with OH minus. Example: potassium hydroxide. These are the strong bases. NaOH and KOH are strong bases. Now coming to the weak bases. First one is aluminum hydroxide. This aluminum hydroxide often found in deodorants. Second one is ammonium hydroxide. It is also used in many cleaning products. Okay. So bases, generally these are bitter in taste. They turn red litmus to blue. Whenever red litmus can be contacted on basic medium, then red litmus can be converted into blue. They give OH minus ions in aqueous solution. They are soapy in touch. Examples: strong bases NaOH, KOH, calcium hydroxide. Weak bases ammonium hydroxide. Now alkali. We know that alkali is nothing but I explained the term alkali. Alkali is those bases which are soluble in water. It's called alkali. So all alkalis are bases, but all bases are not alkalis. Okay students, most of the acids and bases are corrosive in nature. They can corrode to the skin. For example, sulfuric acid is there. It is a corrosive chemical. So you don't try to taste and even touch with bare hands. So don't play with acids and bases. Then how can we identify whether the substance is acid or base? Yes, we can identify based on indicators. Based on indicators. So what are indicators? First of all, so once look at slide. Yes. So generally indicators are also substances. Indicators are also substances which change their color, smell in different types of substances. So these are the substances to identify whether the substance is acid or base by using color or smell. Now what is the classification of indicators? So indicators can be classified into different types. First one is natural indicators. So natural indicators are nothing but those are the indicators found in nature in plants called natural indicators. So examples: litmus paper, turmeric powder, and red cabbage, etc. So once look at the board now. So litmus is the natural indicator. So litmus solution can be obtained from lichen plants. These plants belonging to the Thallophyta group. Okay. So litmus can be available in two papers, that is blue litmus paper and red litmus paper. Blue litmus paper and red litmus paper. So in the acidic medium, blue litmus paper can be contacted. When blue litmus paper can be contacted on acidic medium, then this blue litmus paper can be converted into red litmus paper. Whereas when red litmus can be contacted on basic medium, it turns blue. If blue litmus paper can be converted into red, that substance we can say as a acid. If the red litmus paper can be converted into blue, the substance we can call as a base. This is about litmus. Okay. Now another natural indicator is turmeric powder. Turmeric powder. So turmeric powder in the acidic medium, it shows yellow in color, whereas in basic medium it shows red in color. So turmeric powder is one of the example for natural indicator. It shows acidic medium as yellow in color, it shows basic medium color as red. Okay. Next, another example for natural indicator is red cabbage. Red cabbage. Red cabbage. So red cabbage is also one of the example for natural indicator. So red cabbage also shows different colors in different media. In acidic medium, red cabbage shows green color, whereas in basic medium it shows purple in color. So another indicators are there. So several indicators are there. So those are beetroot, petals of hibiscus. These are also considered as natural indicators. Okay, so, okay students, in this we have discussed what is meant by acid, what is meant by base, how can you identify whether the substance is acid or base. Okay, in next session we will discuss about what are the artificial indicators.